My name is Joe Romano. I'm with Langen Engineering and Environmental Services. We are a multidiscipline firm, integrated one-stop shop. We offer mostly ground-down services. As you can see from this, they're mostly founded in the geotechnical and in the ground-down environment. I run the survey group for the firm. The firm is a 44-year-old firm. Mostly catering to private development. We do have some public sector work, but mostly on the private side. Today we're about 820 people spread out across the world. Most of our offices are in the U.S. We have 21 local offices and 5 overseas and 1 planned in Central America soon. And so it gives us a breadth of reach, which is pretty good. I'm not going to spend a lot of time on the firm, so I just wanted to give you some background about who I am and where we come from. Like I said, Langen is about 44 years old, and I've been here 32 years. I spent my whole career here. So you're probably wondering why is a surveyor talking about BIM or data capture? And I want to give you a little background about that first before we show some examples. The world we live in is a world of 3D documentation, whether it's for a topographic survey or for a boundary survey, an air rights survey, or for an existing conditions BIM model. In our mind, it all starts with accuracy, and you only get the opportunity to collect data once, and everyone on this call, I'm sure, knows that once you get a piece of data in the computer, you can report it to almost any accuracy you want. That does not make it any more accurate. So we kind of approach what we do from that end. A little history about, we're going to talk mostly about scanning for the data acquisition method here. So a little history, Ben Casera is the founder and the grandfather of the scanning world. He put in 1996 the Cyrex scanner on the market, and he took that from, he was mostly in the oil industry, and there's a massive amount of data in that world. I think we all know why BIM is important, and I really like these photos. It really shows you how things get messed up. So for those of you who don't know, the way scanning works is it's a spatial instrument. It collects 3D data. We set the scanner up in a vantage point, and it records horizontal distance, vertical angle, and horizontal angle, and it does that depending on the scanner. It can do that to 1 million, 2 million times a second. It's a massive amount of data. Each one of those points is accurate depending on reflectivity of the surface that you're acquiring and some of the other conditions, but the accuracy of that can vary, and it also varies with the scanner. There are many different flavors of scanners on the market, and they range from some high-end ones to some lower-end ones, and they all have their place and their method. Every time we set a scanner up, it's called a scan world, and we use a host of ways to place those scans together and create one final point cloud. That is where some of this survey technology or survey history comes into it, and some survey knowledge. Early on, when scanning was first marketed, it was marketed to surveyors. But part of the problem was there was no way for us to use any of this data. A lot of earlier scanning projects were done just like this one to create a historic documentation of a facility or a digital documentation of a facility for some records. And in fact, Ben Casera founded an organization called SciArc that's their whole purpose. They go around the world and they document sites like this site so they can live on for the future. But we started scanning in 2002 is when we really started looking at it, and we saw it as an opportunity, and we thought there was some also good timing here. It is we kind of came up with creative non-survey based uses of the scanner, and the reason I said that is because, again, it's a lot of data to use in a traditional ground down survey environment. If you're doing a topographic survey, there's a lot of data here, and the files are very heavy. In 2002, all the way to 2006, really, the software that we used to create this information was really in its infancy. Even the hardware could not handle the size of some of these point clouds. But we leveraged our existing client base, and we brought them, the ones that understood the 3D environment, we helped them understand workflows and how to collect data and use it for accurate 3D documentation above ground, interior spaces, or railroads in this instance. And our first project there on the left was a little church that actually blew up, and our job was to recreate these windows that could be prefabricated to go back into the new church. And this probably took 4 weeks to create this whole drawing. In 2006, we got a little better, and we were creating cross-sections and profiles of some data. If you fast forward that, today we create full Revit-based existing condition models, and they're what we call survey-grade models. We came to that road because we saw that the GSA was giving out existing condition BIM contracts, and we were fortunate enough to win a few of those. That helped us understand some of the workflows and some of the advantages and disadvantages to 3D capture. And again, there was a lot of learning steps here and a lot of hard lessons, but I think we've gotten to the point now where there's some really good service providers out there that can collect this type of data for you. And also the software and the hardware advancements, just like being able, even this today, to show a live webinar of some videos wasn't available back then. This is, I was talking earlier about using it for topographic mapping, and there's a lot of data here. For those of you who work in a civil environment or a roadway environment where you're just doing cross sections, this is a lot of data just to pull out a cross section of a road or a bridge height as shown in the bottom. But there are advantages. So in an area where you can't do a road closure or you're in an unsafe environment, the scanner lets you pick that data up without putting a surveyor or an engineer or somebody in harm's way, and it's a great tool for that. It's also, again, in an area where you cannot easily access, or you have to have, in this instance, a track closure, which is very costly. If you're putting a surveyor out there on the track, this can be done remotely, and it allows you to pull up that survey-grade data and then produce models from it. These two models that you're seeing here on the right are actually 3D PDFs, which is a very good tool that we found is useful for providing our clients with an easy accessible and easy viewable representation of the model. So you don't have to, again, the files are very heavy. Sometimes you need specialized software to view it. This allows for almost anybody to use and view the model. Early on in the projects, in our history of doing this scanning work, contractors were one of the, believe it or not, contractors took the lead on what we were doing. They saw the advantages early on of being able to prefabricate and understand the existing conditions before they went into a space. And this model here is probably familiar to a bunch of people, the building, but this was one where we did not do a lot of the modeling in-house, and it is what led us to now we do all our modeling in-house, and it was a lesson learned on our part, and that lesson was controlling the data. We had shipped this out to be modeled to a sub-consultant, and it came back and it was not representative of the whole point cloud, and we decided at that point to do our stuff in-house. And you can see a couple times through that point cloud, you could see targets on the walls. Those targets are what we use to control the point cloud and control the point cloud to get it into correct horizontal and vertical datum. Being a firm that does multiple services, and as BIM has evolved, more and more agencies are now starting to look at BIM-enabled deliverables. So we have to come up with a way or a workflow that allows us to bring our traditional services into this environment. And this is a campus-wide 3D model. We scan the exterior, even though I said earlier we usually don't scan topography. The image on the bottom left is the mass model inside Revit with, you can see through the building and see some of the floors. So the idea here was to build a new addition to this building in the parking lot with tie-ins at the second and third floor of that glass building. On the right, we combined it with our traditional survey services where we used the utility data and even the foundation plans for the existing building and modeled all that and supplied one full Revit model. There's still some glitches on our side on the Revit for topography, and maybe George can touch on some of that when he speaks. A lot of our work is MEP work. This is a hospital, it's U.S. on the East Coast. We were hired by the contractor here to help them understand all the existing conditions. This is a middle floor that was going to be repurposed, and they needed to understand the MEP above and below it, and they wanted to prefab as much as they could prior to, so they would have as least interruption as possible. Often we're asked what happens when the pipe goes in. You know, a lot of times you have a pipe go in a wall at one elevation, come out a wall at another elevation. There needs to be a lot of conversation between the data provider, us, and the rest of the team to make sure that those things are understood. Otherwise, a lot of fingers get pointed at. My guys really like too being in the scrubs here. They all thought they were doctors. This is the final model of that product, of that project, and it's a very, very, very heavy file to transfer, and we transfer data like this most of the time by mailing and FedExing hard drives back and forth. This is a infrastructure project. Again, it's all completed inside Revit, and I don't know if my mouse is viewable, but the image in the upper right is going to be, this is a double-decked roadway, and this area is going to get filled in by multi-story towers and parking decks, and they needed to understand how this facade related to each other in 3D. And this was a great tool for the team to use to understand that information. So here's a quick fly through of that. And again, this is all Revit-based survey grade type of information. The team who worked on this project, the architect was actually in London. The owner was here in the U.S., and we did this by using a local surveying firm coupled with our own surveyors who flew out there and did some of the work. Harry touched on 3D printing. We use 3D printing a lot. You can see on the upper left there's a proposed, actually that's a proposed Lowe's where we brought it to a planning board. It's really good for an MEP tool. It lets people touch and see what's going on, and the office space on the upper right. We were asked to create a model of a tree for an artist in Central Park, which Microsol was able to do for us. It was a pretty interesting use of capturing data in an environment we never thought of. That's one of the cool things about doing this. I mean, we have 7 of these scanners running around, and it's brought us to a lot of unique places. What's coming up on the horizon, you might have heard about mobile mapping. It's a system that is integrated on a vehicle. It uses GPS, multi-survey scanners, multi-scanners, and this one uses video in conjunction with video. And it allows you to, this one here in particular, allows you to work in the video, but referencing the point cloud in the back. And we're starting to see where it allows for automated data extraction. It'll do signs, edge of road, it'll do some utility poles, and it brings that into a GIS world. The images in the bottom left that are moving around, you may see them ghosted because you can actually see them in 3D with 3D glasses. I think this is a really cool use of the technology. What's coming up in the future, you can see drones. Everybody's heard about drones or UAVs or UASs. Everybody has different terminology for them. There's 3 images. There's the one on the upper left and the bottom right are rotor-mounted helicopter-based one. We own the one on the bottom right, and we're working closely with the university with a university to fly these. If you heard on the press, there's a lot of negative press, and some the FAA is issued licenses for some universities to fly it. The bottom left is a very interesting project. That's a scanner mounted to a drone, and that's flown in France. It's pretty cool technology. And the upper right is an image supplied to us from Autodesk, and it's an image of using reality capture using photography. And George is going to touch on that a little more, so I'm going to skip that. One of the other problems we saw early on was there's no standards. Anybody who's on this call and wanted to hire a survey provider, they would not know where to go to get that, a blank RFP. The AIA has templates for design, level 100 to 500, but that's mostly design related. So a few of us got together and we put together this organization called the USIBD. Welcome anybody to visit the website. There's some downloadable RFP templates, and we're working on some other templates. There you can also get some information on standards through the GSA. They have 2 books, and there's this also, the International Property Measurement Standard Coalition, which is also trying to put out standards. But we think that standards will be very important, again, because the accuracy and the downstream use of that accuracy is important to not only to the provider, to the designer, and to the owner. And last, there's some considerations here. The project requirements, does it need, what type of data, reality capture do you need? Are they long-term assets? People that have long-term assets can leverage the downstream use of it again over and over, and that's where that accuracy the first time plays into that. And you can do that by making it a team event and making sure that everybody that you can think of that need that data get involved with collecting the data and the specifications that are required for it. There is a large upfront cost, but there's a large return. There is no easy button. There is some software that George will touch on that has made this more automated, but there's still a heavy user interface. So while the field work is collected quickly, some of the office work is a little bit costly and time inherent. The workflows and the procedures will evolve. I think the rest of these are pretty, self-explanatory. One thing that's not, you got to be open-minded, and you got to find a service provider that's willing to educate you and educate the team on the use of the data and the horror stories, the pros and the cons of using it. Otherwise, what we've seen happen is somebody will become a naysayer in an organization, and they'll discredit the technology as opposed to discrediting the provider. So I think that's pretty important.